Good afternoon and welcome to the PASS Database Administration Virtual Chapter meeting. My name is Julie Bloomquist. I'm the moderator. And today we're going to be talking database benchmarking, mysteries, myths, and misconceptions with Bert Salzo. We wanted to thank our sponsors. They help fund the raffle for our user group. We have Quest and Swiss. Attend the PASS Summit and grow your career. It's one of the top, it is the top, I think, conference for SQL Server. It's November 6th through 9th, and there are also pre-conference classes prior to the summit. If you want to register for the summit, we have 2 discount codes. One will give you streaming access to all of the PASS 2017 content, and the other one will give you a $150 discount. PASS is going to start up a newsletter soon in August. So you can go to your PASS login and sign in and update to set your subscription preferences. They're going to be launching DBA, developer, and BI newsletters. There is a knowledge partnership program, and we're looking to grow our relationships with partners by enabling them to contribute educational content to the different groups. You can learn more about partners. We are one of many virtual chapters. Here's the list. You just take your PASS account and associate with a virtual chapter, and you can also associate it with a physical chapter if you have one in your area. You will only receive emails about meetings. SQL Saturday is a one-day mini conference. Here are the ones coming up around the world, and they have multiple tracks, you know, like developer or database administration, professional development. Sometimes they also have pre-conference or post-conference classes as well. The fees are nominal and usually just cover the cost for the lunch. PASS now has information for growing your career. And here's other ways to stay connected with your free membership. Again, today we have Bert Salzo talking about database benchmarking, mysteries, myths, and misconceptions. Bert's a renowned database expert with Oracle, ACE, and author and chief architect at HGST with 3 decades of database experience. Bert's webcasts garner high attendance and participation rates. He's also has an extensive academic background that includes a BS, an MS, and a PhD in computer science, as well as an MBA. He's written 2 books for SQL Server users, The Introduction to SQL Server Basic Skills for Any SQL Server User Database, and Benchmarking, Practical Methods for Oracle and SQL Server. I'm going to switch the presentation over to you. And there you go, Bert.
Okay, welcome everybody.
I see your screen. Yes, you're fine.
Great. Welcome everybody. This is going to be a fun topic. It's also a very interesting topic. And as she introduced, my name is Bert Salzo. I've been working with all databases for over 30 years. So Oracle, SQL Server, Postgres, DB2, MySQL, Sybase, the list goes on. I've written quite a few books, including an introduction to SQL Server. I also have written a database benchmarking book, and I have a brand new database benchmarking book coming out in Q4 this year. The first question a lot of people ask is, well, why the heck do I need benchmarking? You know, why would I be interested in listening to this type of presentation? And the reason is, at some point, your management's going to ask you a what-if question. What if we virtualize our databases? What if we consolidate? What if we move to an open source database? What if we upgrade our servers or buy new servers? Or what if we want to compare one server vendor to another? Or how about we're moving to the cloud? Which cloud provider should we pick? What size image? What type of storage should we use in the cloud? Should we use their disks or their NVMe or flash or SSDs? So there are a lot of choices. And how do you answer a question if someone says, well, what if we do this? Well, a lot of times you need to benchmark or test to see what that new system or that change in the system would do to your database performance. And so this type of tools and these type of techniques are going to be useful to answer all of these what if questions. Now, there is winning and there is misery. I'm not really a big Bill Parcells fan because I'm a Cowboys fan being here in Dallas, but I like what he has to say, which is there's winning and there's misery. And that's part of the title in this. There is misery in database benchmarking if you don't do it right. And then J.R.R. Tolkien, the Lord of the Rings author, I believe legends and myths are largely made of the truth. So there's the myths behind benchmarking. And then one of my favorite authors, Edgar Allan Poe, stupidity is a talent for misconception. There's a lot of misconceptions in benchmarking. So that's why I picked these three particular sayings, because they actually go with the title of the presentation. Most database benchmarking efforts fail miserably. So we've got the Titanic, the Hindenburg, and then something a little more modern or new with the Challenger spacecraft shuttle explosion. Honestly, most of the database benchmarking efforts that I get brought into late to help people try to salvage, they fail, and they fail miserably. And we're going to look over all the reasons why people fail and how to avoid those types of issues. So why do they fail? Well, the first one is typically they have insufficient time. I'll go into someone and they'll say, we have 2 weeks to do a benchmark. We don't have the hardware in yet. We don't have anything configured or set up. And we want to do a 10 terabyte data warehouse. And we got to do all this in 2 weeks. And loading a 10 terabyte data warehouse might take 3 to 5 days just to load the data. So in reality, once you get the equipment set up and the software installed and the data loaded, you're out of time. Typically, you should be thinking about more like 4 to 8 weeks, possibly longer, depending on what you're testing or what you've been asked to formulate an opinion on. For example, if someone says, benchmark the 3 major cloud providers and tell us which one works best for our needs, you're not going to get that done in 2 weeks. The other thing is, a lot of times they will assign people with the wrong skill set. You really need to have a strong database knowledge. You can't just be a database user or a developer who has worked with databases but maybe doesn't know all the ins and outs of how to optimize, tune, and configure that database. You also should probably have good operating system, network, and storage skills, and probably even cloud skills. Sometimes someone will want to do a benchmark and they'll say, I want to know how big a system or how big a database we can put on this system. And they've ordered a system that's too small or too large for what they're trying to prove. And so, or they may have the wrong software. Maybe they have SQL Server Standard Edition and they needed Enterprise Edition. So not knowing or having the proper things at hand. A lot of times people also will just take hardware and software and just install it and use it out of the box with all the defaults and try to do benchmarking to prove or to find some magic number. And those numbers are going to be skewed by the fact that they didn't optimize the system for what they're trying to do. But I think the biggest problem I run into is the lack of benchmarking knowledge. No one reads the benchmarking specs. They go out there, they download some tool that says it'll run a benchmark for them. They fumble their way through the tool, answering the questions that they're not really sure how to answer because they haven't read the specs. And then they get results, and they're not really sure what they should measure, why they should measure it, or how to interpret those results. And we're going to cover all of that today. The most important thing, I was a Boy Scout uh, as a youth. Be prepared. That's probably the only thing I remember from Boy Scouts, but it's, if you're going to do benchmarking, preparation is key. This will eliminate most of your failures. Benchmarking is not easy. It's sort of like that Olympic weightlifting or like Atlas with the world on his shoulders. What I like to show people is there's that Staples big red easy button, you know, like shop at Staples. You push the button and everything is easy. Well, there is no such thing like that in benchmarking. You cannot download a tool, push a button, and get anything meaningful out of it. If that's what you think you're going to do, skip it. Just create some artificial results and publish them, because it'll be probably just as accurate as trying to push a button without being prepared. A database benchmark is a lot like a cardiac doctor, the cardiologist. So when I go to the cardiologist and he wants to know how well my heart is doing, and do I have any issues or problems, or how hard can I press my heart? He sticks me on a treadmill, my sweatpants. He sticks all those little things on your chest. He hooks you up to a monitor and he stands there, and the treadmill makes you sweat. He runs that thing at some incline and at some speed to make your heart work harder. That's what a database benchmarking tool is. It's a treadmill. It does not monitor. It does not optimize your hardware or software. It does not tune. It does not give you advice. All it does is it makes the database sweat so that you, the expert, with your monitoring tools, can observe and come to conclusions. And so that's another problem. People think that, hey, the benchmarking tool is going to do this whole picture. It's just the treadmill. You have to decide all the other issues and how to interpret those results. Some common failures. Well, a lot of times it's the wrong person doing the benchmarking. So I got Homer Simpson there replacing the weightlifter, or someone will try to do the benchmarking and they got the treadmill, but they really don't know how to use it. So there's an anvil sitting on it, sort of skewing the results because they haven't read the spec or looked at other benchmarks that were done on similar hardware and software to what they're trying to do, to have some kind of preconceived notion of what they might get. Or it could be the wrong person doing the job, or it could be the right person doing the job, but he doesn't have the monitoring tools. So there's a lot of places where you can have these failures, and I have seen every possible combination of these. So the first thing is you want to know the industry standard benchmarks. Now, you may or may not want to use these. You may say, well, my system is special. My database, no benchmark can approximate what we do. In that case, what you probably want to do is workload capture and replay. And that, I would argue that that's a type of benchmarking, but it's specific to your application. Not a lot of people, though, have the ability to do a workload capture and replay, because depending on your database, either the tools exist, but they're expensive, or the tools exist, but they put too much overhead on production, or the tools exist, but you're being told you can't use them in a production environment because of fear of overhead. So a lot of times you will have to revert to just, I'll use some benchmark that I think comes close to what we do, and I'll use that to try and come to some kind of conclusion. If you're in that scenario, then the first thing you have to do is decide, well, which benchmark is like what I'm trying to do. And there's the TPCC and the TPCH, which are probably the two that most people know. One is an older OLTP benchmark, and that's the TPCC. And the TPCH is an older, very basic data warehousing type or reporting type benchmark. It's not a star schema. It has 22 complex queries, and that's all it does. There are newer benchmarks, the TPCE, which simulates an online brokerage system. So it simulates like E-Trade, or if you were at Fidelity or Vanguard, on their website doing, stock and mutual fund trades and things like that. It simulates that. There's the TPCDS for decision support. It's the new data warehousing benchmark. It executes 99 really complex queries, and it does in fact include a star schema design. Then there's the TPC-DI for data integration or ETL, and the TPC VMS for virtualized database systems. I think the first four are the ones people use the most. The first two are the older ones that most people probably are comfortable with, and the second two are the newer editions of the older ones that you should probably start looking towards. Know thy test. If you don't read the spec, and some of these specs are 100 to 200 pages long, I get that, and no one likes to read 100 pages of stuff if they don't have to. But if you don't read the spec, and the benchmarking tool asks you a question like, you're running a TPCC, what scale factor do you want me to do when I create the database? What's a scale factor? Well, if you read the spec, you'd know what that is. If you ask the tool, it's probably just going to say it's what the TPCC tells you is the information I need in order to answer this question. So at some point, you have to answer the spec or read the spec, or you can't answer the question. Or what a lot of people do is they answer the question, then they get the wrong results. And I'll give you an example why. For the TPCC, when the benchmarking tool asks you for a scale, most people think that means, well, that must mean the size or the number of virtual users, and it doesn't. It means in this order entry system, how many warehouses do we have across the country? So that's a very different question with a very different type of answer, and the only place you're going to find out about it is by reading the specs. Otherwise, using the benchmarking tools, you're just going to be pushing buttons and guessing. Another thing you want to do is you want to understand the database design. And I'll give you an example why. This here for the TPCC, I know looking at this and then looking also at the spec at the type of transactions, I know that the spec is designed to have one table that's a hot table that is going to be a bottleneck. It's done that way on purpose because that helps to stress the system so that you can get, meaningful answers or results. Knowing that, then I don't overreact if I see in my monitoring tool a particular table, let's say it's the district table. If I see that I've got a lot of weight type events on district, reading the spec, I would probably know that's typical. Don't panic, because that is the bottleneck table, and you should see that type of activity there. Also notice for each active warehouse in the database, you can accept transactions from 10 terminals. What that means is if I want to do a 1,000 concurrent session or concurrent user benchmark, I must size for 100 warehouses because each warehouse can do 10 terminals and a terminal is a user. So when it asks you what scale you want, it's kind of asking you how many users are you going to run, but it's doing it indirectly, and you have to do this little bit of math so that you answer the question appropriately. Now, the TPCH, on the other hand, is a very simple reporting database design. This is not a star schema. And when I look at this design, I can get an idea of when it asks me for a scale factor and I say 1, I know that means that the biggest table, the line item table, will have 6 million rows in it. And if I say 10, it's going to have 60 million rows. And if I say 100, it's going to have 6 billion rows. And so again, knowing the scale factor or knowing that the tool is going to ask me for a scale factor, looking at this, I can then know from the spec, what's it asking me and what do my answers mean? Sometimes when I am working on a benchmark, I will even go use some data modeling tool. One of our sponsors, Quest, actually has a data modeling tool called the Toad Data Modeler, and I'll reverse engineer the database design that the tool produces, just so instead of having this kind of diagram that might not mean a lot to me, that I have something that I'm more comfortable with working, which is a typical ER diagram. I'm not saying you have to do this, but it's not a bad thing to do if you have questions. Also, a lot of times, especially in a data warehousing test, people will say, well, gee, can I partition the tables? And the answer is, well, if your database edition allows you to, sure. But does the benchmark specification allow you to, and are there any restrictions on what you can do? And the answer is yes. You have to read the spec to see. And in addition, this is something that's kind of problematic. All but one of the database benchmarking tools don't offer to automatically partition the objects. And you might think, well, is that because they don't implement that feature or because they're lazy? And the answer is no. They don't know your storage subsystem. You know, how many LUNs you have and how many spindles that spread across, or whether you have SSD or flash or NVMe. They don't know that, and they can't guess. So they're really going to create for you the tables as required, but a good DBA is probably going to alter or modify those to make them more efficient. And I'll talk more about that later on where you get advice for that. Also, you'll note from the spec, it says, hey, you should collect statistics. I know that in the Oracle world, for example, everyone collects statistics. And in the SQL Server world, I find a lot of SQL Server DBAs who either don't do it or weren't even aware that they could do it. So again, for benchmarking, it is desirable to collect the statistics. Now, this is the TPCE, and I reverse engineered it into a data modeling tool. Remember, this was the test that's going to be like a online brokerage system like E-Trade. This looks like a real world data model. I wanted to show you this because usually when I show people the prior couple of pictures, they're like, well, those are artificial databases. What can they really tell me? This is like a real world database design. This is typical or something that might look like what you would have built. So this is actually a very meaningful test. And if you're wondering, well, okay, so now we've seen the TPCE, which is the OLTP type. What about the TPC-DS, the decision support, the new data warehousing one? It's a star schema design, and here are the first 4 stars in that design. I'm only showing the tables here. I'm not showing the breakdown into the columns with their data types in that because it's just too much to show. But what I wanted to show you is there are, in fact, 7 different stars in this design, and there are 99 different very complex queries that hit this design. And so it helps to have this kind of picture in your mind so that when you're running the tests, you know what's going on and how to interpret the results, and also how to maybe optimize the system to get the best results. Now, there are a lot of great tools out there. One of them used to be called Hammer Aura because it was an Oracle-only tool. It's now called HammerDB. It has the TPC-C and the TPC-H, and it works for about 6 or 8 different databases, including SQL Server and Postgres and MySQL and a couple of others. And so this is a pretty good tool. Sometimes I find that the SQL Server guys are hesitant to use it because it started as an Oracle tool. I get that, but it's HammerDB now, and it works for lots of databases, and it's a pretty darn good tool, and it's free. My favorite price. There's another tool called SwingBench. It has 6 different benchmarks in it. It's the only tool I know of that has the TPC-DS, the decision support. It's also a free tool. And both HammerDB and SwingBench have the ability to do workload capture and replay. They're kind of basic mechanisms, but for some people that works, especially if you're in a database like Postgres or MySQL, where maybe you don't have a database capture and replay built into the database, and so you have to look to a third-party tool. And then likewise, there's a tool called Benchmark Factory. That's from one of our sponsors, Quest. There's a free version that's really good. You can only do up to 100 concurrent users for free. If you want to do a 10,000 user or a 50,000 user benchmark, you've got to pay for the tool. But it's pretty darn good, and it does the TPC-C, E, and H, and it works for, it's like 6 or 8 databases, including SQL Server. So it's pretty good. Some misconceptions when benchmarking. I'm using one of the free tools, or I bought the Quest Benchmark Factory, the commercial tool, and that's all I need. I'm going to go push a button. Again, if you haven't read the specs, it might ask you questions you don't know how to answer, like that scale factor question. So you have to read the spec to find the answers to those kind of questions. So you can't just buy a tool or download a tool and push buttons and get results. I have this really expensive storage area network, and so I don't have to worry about I/O. Or I've put everything on NVMe disks or SSD disks, and so I don't need to worry about anything. I have seen where we have done benchmarking, where we have gone to their storage area network into the firmware, which was, let's say, set up by default to handle OLTP workloads, and we were doing a TPCH or data warehousing workload. And so the read ahead and cache settings were not optimized for the type of workload we knew we were going to do. And by changing something at that low a level, we actually were able to get a 500% difference in our results that we achieved with the benchmarking tool because we changed something in the storage area network. The other problem I run into is a lot of times, and this is I run into this a lot with SQL Server shops, less than I do, say, with Oracle shops. Everyone puts stuff on RAID 5 because, hey, it's RAID, so that means it's good, and it's 5, which means, I don't lose too many disks. RAID 5 has high, and actually RAID 6 as well, high write overhead. So if you're doing an OLTP test that has, let's say, 10,000 concurrent users or 50,000 concurrent users, choosing RAID 5 could be a limiting factor. So notice that this has nothing to do with the database. We're at the storage level, looking at storage firmware settings and the RAID construction for setting up our LUNs. I can just use the default operating systems. Actually, I'm going to show you on the next page a simple thing you can change. One little thing at your operating system that can give you between 50 and 150% difference in your benchmark result. If I'm on SQL Server on Linux, I will change something called the no A time setting, which basically says, hey, file system, every time the database touches a file, whether it's a data file or a log file, you don't need to log that information at the operating system with a date and time stamp because the database is already doing that internally. Likewise, over here on the right-hand side, you can do this in Windows as well. And that includes Windows servers as well as Windows desktop. It works for both. I'm not saying you should blindly do this. There are some downsides to these types of settings. If this server were both a web server and maybe a file server and a database server, I probably wouldn't want to do that globally. I might only do it for the file systems or the devices where I had the database files and not, say, the file system files, because their date and time stamps are important. So be careful. It's a great tool. Most people, like I said, aren't aware of it, and it gives you anywhere from 50 to 150% performance. Another thing I've run into is people will say, well, I just use SQL Server out of the box. I didn't really worry about changing a lot of settings like the memory allocations or where I put my files, what my file growth settings were, whether it was automatic, and what percentages or what grow by what amount. Another one I've run into is people will have SQL Server on VMware and they'll have the wrong settings for their virtual machine. So even though they say, well, I gave this virtual machine 16 CPUs, in their mind, they find out that they're only using 4 because they set the way they did the settings for the number of sockets and the number of cores per socket doesn't allow them to maximize, because on your SQL Server license, for example, on Standard Edition, I think it's 16 threads or 4 cores, whichever is the lowest. And if you don't know that and you set it wrong, you could only be using a small percentage of your CPUs, and you think your database is slow. In fact, it's not. It's that you've got the wrong setting. So I've seen as much as 533% improvement. And where that shows up typically is the average response time. So that purple line from run 1 is nowhere near as good on the average response time for a transaction as, say, run 5. So that's where I'm getting the 533%. Tools like that Benchmark Factory, and I'm not picking on it, but all the tools, will optimally create your database objects, the tables, the indexes, the partitioning, and all that stuff for my hardware and for my database setup. No, they're going to create the default standards required by the spec. And if you want to improve upon them, you should read in the spec. Now, Benchmark Factory does have the ability to auto partition, but basically it does it using a best guess method that will work generally speaking, but really doesn't understand your hardware and really doesn't take into account other factors that might be important to you. So while it could do it for you, it takes sort of a wild best guess. You probably can do better. So don't rely on the tools to do everything. I said this before, these tools don't monitor, tune, and optimize everything. That's you. They're the treadmill. They make the database sweat. Number 7, I love. I don't need a DBA to do this. I can download a tool, push a button, and it's going to produce some magic number that means something. No, you really need somebody who's a database professional and who knows networks and OSs and storage and cloud. Another one that's interesting is people will say, well, I'm moving from SQL Server to Postgres, or I'm moving from Oracle over to SQL Server. And I can make a one-to-one comparison between these vendors on the same hardware platform. It depends. Sometimes yes, sometimes no. If you've read the spec and you've got really good people who are used to benchmarking, you probably can get numbers that you can do a comparison with. If not, if you're just sort of flying by the seat of your pants, the numbers may not look that good. I've seen where out-of-the-box Oracle can look sometimes 2 to 3 times slower than out-of-the-box SQL Server. That's not a surprise to me because I know from Oracle that it's really set up to be finely tuned and configured rather than running out of the box, well, right from the get-go. And so if I didn't know that, I'd think SQL Server is just automatically faster, and that might be true, but it wouldn't be true by the results I looked at because I might not have set it up properly. This is an important one. Transactions per second. All the DBAs I talk to, they all focus on transactions per second, like that's the magic number. And then they don't look at anything else. So let's pretend I'm looking at these runs here and I've changed some settings in my storage and my operating system and my database, and I look and I see that run 1 in purple versus run number 5, that the transactions per second, they're generally better under 5 by maybe at most 25%. So that's great, But is that really the truth? I mean, I've shown you the same chart earlier, that in reality, it's 533% better. So if I had only looked at transactions per second, I might not see a very important fact, which is while it looks a little better on transactions per second, it's a hell of a lot better on average response time. And it's the combination of both of those that's important. So don't only focus on transactions per second. And the other thing is transactions per second are not IOPS, IOs per second. They do not equate to each other. And a lot of times people will say, well, I'm benchmarking the system because I just want to know the IOPS. Well, then don't use a database benchmarking tool. Use a storage system stress testing tool rather than the database benchmarking tools. I've already mentioned this before. You can just spend a few days and you'll know or be able to get everything done. I think the other thing that I didn't mention was, so let's say that you're going to do a big data warehouse. Let's say a 3 terabyte data warehouse, although that's really not big by today's standards, but let's say you're going to do that. And let's say it takes a day and a half to load the tables and then a half a day to create all the indexes and collect all the statistics and to get everything prepared. Well, if you do it right the first time, and I can tell you, I would never do it right the first time. There's always iterations. It takes 2 days at the least. And if I have to run it 2 or 3 times, I've already used up a week to a week and a half possibly, unless I'm working weekends too. So count on you are going to iterate. And here's why. You're going to run a benchmark, you're going to get a result you don't like, and the light bulb's going to click and you're going to say, oh, I can redo that test and make these changes. The spec allows me to make those changes. And I understand now better what the tool's asking me to do, and I'm going to get even better results, or more meaningful or more accurate results. And so you're going to have to wait another 2 days for the data to reload again. So now I don't do it that way. You might say, well, gee, why don't you load the data, do a backup, run the benchmark, and then if you need to run it again, just do a restore. I do that, but guess what? That's all manual because none of the benchmarking tools do that automatically. But that's how I do it. So again, just don't tell someone, hey, in 1 to 2 weeks I can benchmark anything, because it takes more time than that. I actually think that the book I've coming out in the fall, and I'm not trying to to sell you on a book or anything, but I break down all these techniques, like, what I just said there manually. Here's the way I do a benchmark. Here's the 10 steps. And out of those 10 steps, 8 of them are manual and are done inside of like SQL Server Management Studio, and only 2 steps are done to the benchmarking tool. So I'll be doing other webcasts and presenting at other events, presenting chapters from that book. So you'll be able to get the material for free, because I'll present out of the book in those other presentations. Full disclosure reports. Sometimes someone will say to me, here's a hardware that our vendor is recommending, and run a database benchmark on it. And maybe I've never seen that hardware before, or maybe it's bigger and more robust and capable than hardware I've used in the past. And I think to myself, well, I wonder where I should start. I've got 64 CPU threads, and I've got 512 gigs of memory on this particular box, and maybe I've never used a box that powerful before, and I don't know what to expect or how to size things. I can actually go out to the tpc.org website, and if I'm doing, let's say, a TPCH, I can come to the TPCH and I can say, show me some results that other people got. And typically this is by the hardware vendors and by the database vendors. And I can bring up a report and say, I know that I'm doing, well, in this case, I was doing Oracle, and I knew I'm doing an Oracle 11 with partitioning. You would find the same stuff here for SQL Server. You'd come in and say, I'm doing a SQL Server 2012 or 2014 or 2016 with or without partitioning. And then you would look over here on the left and say, yeah, that's the kind of size machine I've got. And I would pick one of these and say, okay, well, tell me what you did, HP or Fujitsu or Lenovo. Tell me how you thought was best to do on hardware that size. And so when I print off this report, there'll be an appendix in there, Appendix B, that will say, this was the optimal way to set up the DDL to create the objects for that benchmark for this type of hardware setup. What's really important is, if they found a special magic combination of indexing and partitioning that are allowed by the spec to give you the best possible results, they have to publish that DDL. And so you can generate the DDL out of the data benchmarking tool, and then you can modify it to fit what the vendor, hardware or software, has told you is optimal for that type of environment. Some of your work's already done for you. You've already got a system that hopefully might even be perfectly optimized now, so that you don't have to spend much time on that. And this is all out there on the web. It's all free to review. Now, I talked about transactions per second versus average response time. Transactions per second gets too much attention. Go to your end user of your database system and say, I don't care that it took 30 seconds to refresh your screen. I'm getting 10,000 transactions per second. And they're just going to look at you like you're an idiot, because they know they waited 30 seconds for the screen to refresh. That's what means something to them. Transactions per second is sort of like looking at your automobile's RPM. Basically, how fast is the engine spinning? But that doesn't tell you how fast the car is moving, and therefore how fast you're going to get where you're going. Also, TPS is not IOPS. It's an indicator of IOPS. A higher TPS usually means I'm getting a higher IOPS, but they are not one for one. And there are reasons why that they are different, and why you would want to focus on one versus the other. So transactions per second gets all the attention, and it's important, but it's one factor out of 2 that are important. The average response time, which gets very little attention, but that's what's meaningful to your users. because they're going to say to you, I don't want anything that takes longer than 2 seconds. If it takes longer than 2 seconds, you have not met your SLA. That is a lot more like miles per hour. How fast this car is moving, because that tells how fast we're going to get somewhere, and it also tells me pretty much how much gas I'll use. But I can't look at average response time by itself either. I've got to look at them together. And this slide helps to bring that clear. Let's say that I'm trying to figure out if this server can handle more than 1,000 users, but less than 10,000 users. I want to find out how many users can this system handle concurrently. And if I just look at TPS, I might think, well, I can go up to about, let's say 1,000 users. So over here where the blue line ends, I can probably get up to about 1,000 users. It's starting to come down, but I didn't lose too much, and I could probably handle 1,000. Over here is the number of seconds or milliseconds for the response time. Now, if our user told us it better not be more than 2 seconds, then in reality, it looks like I better be looking somewhere in between these two blue lines, because somewhere between this blue line of 700 and 800, I crossed that threshold. And what I may find is that maybe that number is very close to 900, but look here, I see an inflection point. There's an inflection point where my transactions per section started to decrease, and it actually is pretty darn close to getting me to my less than 2 second average response time. I would argue that that location right in the middle between those two vertical bars, that is probably your optimal size. You're under your SLA of 2 seconds response time, and you have reached the maximum TPS while staying under that limit. And so when I look at these two numbers together, that is the point that's probably optimal. Now, again, remember, TPS is not IOPS. If someone said, oh, I'm just trying to test IOPS, you really probably don't care about IOs per second. And if you used a different type of benchmarking tool that was really more for testing storage, you might find that this line, when it's doing IOPS, if you had a benchmark to get those results, would just keep going up and up and up a lot higher before it would turn. And the reason is because a database operation tends to be multiple IOs. Your record could span multiple pages or blocks. You could have many indexes that need updated, so those blocks have to be written. You've got the logging activity. You've possibly got auditing activity. And so what you think of is one simple little insert might be 50 IOs in reality at the database lower level. And so you can't look and say that TPS, that one TPS equals one IOP, because it might be 50 or 100 IOPS. So remember that. But look, a lot of times, if you look at these two numbers, you can find the magic point pretty easily. They'll stick out. And with that, I want to open up the session to questions, and hopefully I can provide some answers.
Okay, and I'm not seeing any questions. This is being recorded. If you do have any questions, please ask them at this time, and Bert will answer them.
$5 a question. Come on, someone's got to have a question. Okay, well, if there aren't any questions, I'm on the web. You can find me at Bert. Oh, go ahead.
Let's see, on the last slide.
Okay, on the last slide.
What was the measure? Was the measure a number of users?
Yeah, the number along the bottom is the number of users. And I wanted to see if I could go to 1,000 or 10,000. In other words, I had this unreasonable expectation. Even 1,000 was more than this server could handle. Over here is the milliseconds, and my users had told me we won't accept anything higher than 2 seconds, which would be 2,000 milliseconds. So I can't go beyond here, because I would violate the SLA, the 2-second limit. And I found a point where my transactions per second inflected, or it was going up, 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 and then started going down. And that point was also underneath of my SLA. So I'm going to tell you that that's probably a good point. It's not just because it's the inflection point, but also because the inflection point is below my SLA. I can go here, maybe slightly higher, and get a pretty optimal system set up. Or I can at least report that's the number this system could support. If we need more, if we really need 1,000 users, or if you really want 10,000 users, you need a much bigger box. Or if I'm on the cloud, I need a much bigger image size. Or I need to use NVMe disks because spinning disks in the cloud, there's different storage classes you can get. You can get slow disk, fast disk, you can get SSD, you can get NVMe. Maybe I have a big enough image, but if I want that many concurrent users, maybe I need to be on SSD or NVMe up in the cloud in order to get further and further to the right so I can get a higher and higher number of concurrent users. Good question.
Okay, another one is, do you benchmark on test servers and production servers, or just the production? Or how do you do your benchmarking?
I leave that up to the customer that I'm working for. A lot of customers, you are not allowed to benchmark on production, period. They will not allow it. If they don't, what I typically like to do is find, do they have an acceptance testing system that is close in size, or at least reasonable in size as compared to their production system, if that's where we're going to test. Let's say they wanted to roll out a new storage array. If they're in the cloud, then that's easy. We typically can either make a copy of their production system in the cloud and put that into a separate image and do the testing, or we can take a subset of the data, and I've done that before, where you take a subset, and often when you take a subset of production data, you'll mask it, and then you can do some testing against their actual data. And again, remember, that's more in line with database stress testing, and some of these tools will let you do a workload capture and replay. But if not, then I'll just use an industry standard benchmark. And then in that case, if I'm doing an industry standard benchmark, there's very few times I would be running that in production. There's just really not the need.
Okay, someone missed the part on RAID 5.
Oh yeah, it's very
5 and 6, which is better? I think it was.
Neither. If I'm doing a database and someone tells me they're doing RAID 5 or RAID 6, I tell them I've already built a problem in their database. You want to be RAID 10. RAID 5 and RAID 6, you have multiple writes per IO because it has to write the parity disk information. So when you say write 1 byte of data, you're not writing 1 byte of data, you're writing several bytes of data, and you have to wait till they're all complete before that IO comes back as complete. Now on reads, that's not a problem. But if I'm doing a production database and someone says to me, oh, we do 1 million transactions a day, or we run batch stuff at night and we update, or insert lots of rows, RAID 5 is just going to be slow as a dog. And that's not my opinion. You can go out there and search that on the web, and you'll find that that's the well-known thing with RAID 5 and with RAID 6. Because you have to write the parity stuff, your inserts, your updates, your deletes, your index maintenance to go with those operations, you pay a penalty on IO for writes with anything RAID 5 or RAID 6.
Okay, another one. So the benchmarking will tell me how the hardware/software can run these benchmarking databases. If my actual database does not run as well, then is that where I need to go back to the developers or look at weights and performance tuning on the database?
Yes, that is exactly correct. If you think I've got everything set up properly and I'm seeing weights, or I'm seeing performance that doesn't match my expectation, now it's time to go in and look at the weights or to look at the expensive SQL and see what is it that's going on that's, what is the nature of the bottleneck, or nature in the missed expectation? Sometimes, and not trying to harp on the rate issue, but sometimes I'll be running a TPCC or a TPCE. Those are the two OLTP benchmarks. And someone will say to me, I want to approximate 50,000 users. And that's not an unreasonable number in today's world. And we can't get the results. And eventually, they won't tell me they're on RAID 5. And eventually I'll look and I'll say, hey, it's the inserts in the index management. That's where all the weights are. And they're like, oh yeah, I guess, we're on RAID 5. I forgot to tell you, and so sometimes you will get into that analysis, but it'll bring you right back to a configuration issue rather than necessarily an application issue. Because honestly, typically it's not bad SQL that gets into production. Most developers are very good about tuning their SQL. It's things aren't well configured. Or another thing that happens in a real production database, let's skip benchmarking for a moment. A lot of times when I was on call, if someone said, hey, the batch jobs overnight didn't finish on time, what I would find out is somebody had scheduled two jobs to run at the same time that were not compatible with each other, meaning that they both hammered the database the same kind of way. And by doing nothing more than adjusting the schedule and saying, this job run a little earlier and this job run a little later, and hopefully there won't be any overlap anymore, 9 times out of 10, that would solve those types of performance problems. So it's not always configuration or optimization, and it's not always bad SQL. Sometimes it can be something as simple as overlap of incompatible types of workloads.
For smaller database systems, is it reasonable to not do the benchmarking but load testing by usually using an actual database, using multiple programming clients, example, running multiple threads, each kicking off a connection that execute actual transactions like in the real application usage?
Absolutely. That's what I call stress testing. And for many people, that's the only way they want to test because they don't like industry standard benchmarks, because industry standard benchmarks don't mean anything to them, meaning that their workloads are different. I mean, if I run a TPC E, which is an investment system, and I'm not an investment system, let's say I'm an online ordering system for like Amazon for buy stuff, the workloads are radically different. I mean, one doesn't have any meaning to the other. And so for a lot of people, that is the only way to do it. Just remember though, now with GDPR and other regulatory requirements, you can't have real data in that test environment. In other words, when you copy the data or you create a subset of the data into that testing environment, it better have been redacted or masked. And the problem I have with that is, let's say it's credit card information and it's redacted or it's masked. You've already made the data artificial. So now, do the transactions you're replaying actually really mean anything when you switch to real data? You might actually get skewed results from that. But we all have to live with those security requirements. And so you may find that doing the stress testing may not be as accurate as it was in the past.
What storage system stress testing tools have you used?
Oh God, I listed like 15 of them in my book. Right offhand, I mean, there's too many of them. There's at least 15 of them out there. Some of them are operating system tools. Some of them are provided by Microsoft, for example. Some of them are SQL Server, or they're provided by the database benchmark, the database vendors. For example, both the Oracle and SQL Server have tools that approximate what a database workload would do to the file system. So you're not really running the database, you're running a tool they provided that pretends like it's a database to stress the file system or the storage system. There are just a lot of tools out there. They're very good at finding IOPS. And what I would say is that IOPS, while it's a meaningful number, when you put a database on top of it, a lot of times the expectation you have when you know an IOP number is not met when you put the database on top of it, because remember, a database operation could be 50 IO commands. And So IOPS, while it could give you some indication of what to expect, sometimes you don't get a one-for-one translation. So be careful when using those tools. They're useful, but it's sort of like looking at the stock market and saying that that tells you how the economy's doing. It might be an indicator, but it's not really reality. And I would say the same thing with those tools. They're good indicators, but they're not always going to meet your expectations when you get to the database.
Right, and I've used Microsoft's disk speed
That's one of the ones.
when
Yes.
working, with a vendor. That's the one that they wanted to use, and they wanted to analyze the results for the database. But next question is, with VMs and vMotion, how useful is benchmarking with these servers, since they can change hosts and they can change, what the shared storage is with other VMs, and it can shift often.
Yes, I'm glad you brought that up. I'm able to then tell the virtualization administrator, because it might be VMware, it might be some other hypervisor, but I'm able to go to that person and say, if your hypervisor allows for relocation, here are my SLA requirements. I need these levels. I know I can't have less than this CPU or less than this memory. I can also give them storage requirements, but then I can also give them an idea of my transaction workload and also its profile. Meaning, if I know that I have a high period of activity, let's say from midnight to 3, and then a high activity from 9 a.m. to 3 p.m., I can put that as part of my profile. So when he's looking at what he will allow for that vMotion, he'll put in place rules that don't allow me to be moved from one stressed system onto another system, which may not be a good fit for me based on my profile.
Yeah, I think it also depends on the other servers. You may be pinned to that host, but the other servers may float in and out, which could then cause a problem. It's very difficult with VMs.
It is. Another problem I run into is it's hard to do vMotion, for example. If my DBA has said to the storage administrator, I want the host bus adapters or the I/O interfaces and even the NICs, the network interface cards. If I want all of those done in pass-through mode so that I can have them at the operating system level rather than through the virtualization layer, so that I can get the maximum network and the maximum I/O bandwidth, that may limit and make it so that it is either harder for me to vMotion to somewhere else because I can't get those same requirements in that environment, or I may be pinned to that machine exactly for that reason, which is, I can't be relocated because I'm configured to use direct on some hardware resources. And so sometimes you're not as relocatable. And all of this gets even more complicated in the cloud, because like I've said, with the cloud, I can pick NVMe or SSD or fast disk or slow disk. I can mix and match them, and then I can move them. I can say, well, I was on SSD, it's not quick enough, I'll now go to NVMe. And so there's a lot of things that come into this. And a good example is we did some benchmarking recently on Azure, and we were testing Azure, the cloud, not Azure database. We were just testing for the I/O for some of the new stuff that they had available. And what we found was, depending on your workload requirements, going from disk to SSD, while you might intuitively think it was faster, your workload might be such that it's actually no faster, only more expensive. And that's an example of where benchmarking can help. You can actually test and say, gee, I think my workload is going to be like a TPCDS. It's going to be a star schema data warehouse with really big queries on big databases, and you could run that test and say, well, let me compare spinning disk to SSD to NVMe. And you might find that you can use a smaller image with cheaper disk and get just as good a results, or darn close enough that you can't justify the cost on the other environment. And so sometimes knowing that kind of information, which might not have been using your exact database, but it'll help you to figure out what's the cost-effective way to use all this new stuff in the cloud that, frankly, we're all learning, because it's all evolving. I mean, there's new stuff all the time. There's new network interfaces between the cloud images, and you also then have questions like, well, what if I span regions or availability zones and things like that. So there's just a lot of stuff that's simple, basic benchmarking. Even though you can say it's not what my database will do, it will help you to get a feel for what these new cloud and all these options in the cloud can do, so that you can take a good first best guess on how to deploy your system.
Hey, Bert, do you have a slide with your contact information? If so, can you put that up? That was a request.
Yeah, I forgot to put that in here. I'll add it to the slide deck, which they're going to post on the web.
Okay. Another question, they're saying is probably not common, but how do we benchmark the complexity of n caret n versus log n? I mean, probably a load that worked well with under 1,000 users, but over n, it decreases performance.
If I were testing at the IOPS level, that becomes a very relevant question. When I get to the database, there's so many layers of what's happening in between. It's hard to phrase the question mathematically in that light. And I'll give you an example. Depending on what type of indexing I'm doing or what type of partitioning I'm doing, I might actually have solved that problem by the structural design, or I might have mitigated the problem. That's probably a better way to say it. It's a lot more meaningful in when you're testing just storage and IOPS. That tends to be more meaningful.
Okay. Can you benchmark using batch requests per second instead of transactions per second?
Oh, absolutely. Yes. There are benchmarks that will allow you to do that. For example, I didn't cover the TPC DI, the data integration, but that is a benchmark that's purely or primarily set up to test at the batching level, and that's where you would actually report. You would be reporting in those types of terms. And so that's a good test if that's where your key bottleneck is. Let's say you've got a system that works really great. You have a nightly batch window of 6 hours, and you're finding that that's a problem. You could then use the TPC DI to test ideas without having to use your production system. You could do it on a test system and say, let me test these different configurations or these different storage options. And I'll give you an example of where that happened recently once, where I had a customer who overnight had a batching window that was not going as well as they wanted. And I made a really simple suggestion to them. Hey, this will be very easy to do. Just set up so that your temp DB is on SSD or NVMe. I said, that's a very easy change to make. It's very low risk. And let's see if that does anything for you. It only costs $400 and a few minutes time to set it up. And it solved their problem. They got exactly the performance improvement they needed. I'm not saying it was the world's best fit, but for $400 and let's say a half hour's worth of effort, they got that problem off of the radar scope, and it hasn't come back up. And so, yeah, academically, it may not have been the world's best fix. There may have been some other better thing, but for $400 in a wee little bit of time, we were able to solve the problem. So yes, there will be times where batch activity is more important than transactions per second or even average response time. That average response time might really be average job time in the other scenario.
And it is true that you cannot just compare 10,000 transactions in one database to 10,000 in another. The complexities of those might differ widely. How do you compare one DB's performance to another?
When all else fails, and I know this will sound like a cop-out, but I really believe this. When all else fails, I only care what the users think. And if it's average response time, if one system can get them their answer or have them wait less time for their answer than the other, that's ultimately the proving point, because ultimately I have to meet their SLA. It doesn't matter how fast my database runs, how many TPS, how many IOPS. I can quote all kinds of magic numbers, but if it doesn't get run in under whatever their SLA is, it doesn't matter. So again, I'm not trying to give you a cop-out answer, but that is where the rubber meets the road, where the users say that's good enough. And that's always how long it takes or how long they have to wait.
Well, I'd like to thank everybody for attending the meeting today. Um, Bert, Sharon will send you the question log from the meeting. This is being recorded and it will be posted later this week on our archive page. Thank you again for everyone for attending, and thank you, Bert, for a wonderful lecture on something that we need to be doing as our DBA jobs.
Thank you, everybody. Have a good day.